Okay, so let's give this a shot. See, you guys can see my, I actually am not doing Zoom. I'm doing it the hardcore way here. And hopefully you guys can see this because it will allow you to zoom in and zoom out into the problems that we need to take a look at. Just got to make sure we have good lighting in here. So I'm going to actually kind of set this in so we can see it and go from there. So for, I believe we had numbers 1, 2 for chapter 7. Then I'm going to do an intro to chapter 8. Number 9, okay. And then flipping it over, we had, and there's probably some confusion by me, but I meant to assign 23, which I believe I did, and 20 I'd like to go back over, and number 13 and 14, just real quick, okay? These are just real brief problems. I'm going to go through them real quick. I actually already did the calculations for them, worked through them, look for any issues that might arise, okay? And then we're going to go into chapter 8, all right? And we're going to keep this real simple. And looking at chapter 8, I'm just looking at this. You know, when we look at a stock, for instance, this is a daily change in IBM over 1997, 2017. If you have return right here, actually we have return right here, but if you look at this, this is a fairly normal distribution. The wider it gets, whether, you know, you've got skewedness to one side or the other, etc. In terms of standard deviations from the mean, which would be right down the middle, you know, the fatter these tails get, so to speak, the riskier the stock gets. So just a heads up, any deviation from the normal distribution, and you're going to end up with a riskier stock. So that's why we do look at things like beta, for example, and standard deviation, okay, in terms of volatility of stock. Okay, and that would be, I bet you can count the number of okays I say through this. All right. All right, so before I go there, let's finish these problems. All right, we'll be right back. Let me get my material. Again, just to make sure I got this right, I've got, because I'm assigning group drop boxes, etc. Hargender, Allen, Karina, Hegley, and Karina Sanchez are, and I believe I want to say Thor are in this group, okay? I've got Akeem, Pamela, Daniel, David in one group. Got Kenloa, Jessica, and Naren in another group, okay? And then we have Fabian, Monica, Krista, and Vicky in our other group, okay? So you guys, thank you for doing that, and let's get rocking and rolling. So I'm going to be real, if you guys have questions on these, please let me know, all right? If you get stuck on a particular one. Our test will be semi-comprehensive, and I am probably going to do a little recording on our valuation, okay, using, we'll see how it goes, okay. I'm going to give you this PowerPoint done by Michael Pagano, and he's a pretty smart guy. He actually teaches valuation, okay, just like Dameron from Aswath Dameron from NYU, and they do a pretty darn good job. And this model is a very simple model. We've done it before. I know you guys have all calculated a weighted average capital, cost of capital. I may be giving you guys this short little project right before the test, but we'll see. I don't want to load a whole bunch of stuff on you. Okay, let's get into it. Let's do number 1. Can somebody read number 1? Can I get a volunteer? Sean, thank you. Okay. So, and thanks for being patient with working with me in terms of getting us through here. So I've got rate of return for number one. Okay, we're dealing with a market index here. So Davia market index is 21,000 at the start of the year. This is number one for chapter 7. So I'm going to start going through the problems. And 25,000, it's at a level of 25,500 at the end. The dividend yield on the index is 4.2%. Okay, and then it asks, what is the return on the index over the year? And if the interest rate is 6%, what is the risk premium over the year? Okay, if the inflation rate is 8%, what is the real return on the index over the year? And we really haven't touched much on inflation. We have a little bit about using the Fisher effect, especially in the domestic case within the U.S. In terms of deriving a real return, okay, versus a nominal or quoted return. Okay, so and you can use this for interest. You can use this for all kinds of rates, rates of return, interest rates, and many other items. Okay, so with that said, especially if you think inflation is playing an effect, and this could be over a time in history, we could be looking at historical stocks. All right, so let's check this out. Let me get my problem or my solution. Now that I've done one recording actually for a class, now that it's been at least 2 weeks worth of class that I've had to bow out on, you know, I'm realizing that Zoom would be a good one to use because I can flip back and forth to the PowerPoint, but that's all right. So let me get my solutions here. Give me 1 second and I will find them. They are right here. I've already worked them. And let's zoom in on number one here real quick. Okay. And number one I just read, and I'm looking for my calculator and my pen. Okay. And my notepad is underneath there. Okay. So again, I'll get to this point, get to that one later. What's on the other side of that? The other side is nominal Fisher effect. You guys, when we're working with returns, and remember that in this chapter, let me zoom out just for a second, we did go through beta, how to calculate beta, even though we really didn't get into that. And beta is just, if you're looking at it, it's the covariance. Let's say beta of a stock is the covariance of, it's basically how the stock moves along with the market. Does it move against it or with it or to some degree otherwise? Okay, so you have the beta, which is just equal to the standard deviation, or excuse me, the covariance of I and M, okay, over the variance of the market. All right, so whenever you have two objects, you are looking at covariance, so this would involve correlation in there. Okay, so when we look at this, just remember that this is about the volatility of, how can I say this, the volatility of the stock. Okay, that's related, in this case there's two kinds of risks. This risk just relates to the risk of the market, not the stock specific risk. So the risk in the market, where we use beta, is often called systematic. The risk that is unique, that we can diversify away, is actually called unsystematic or specific risk to the stock. Okay, unique risk. All right, and again, we had kind of gone through, we had reviewed the average betas for the market, which is, average beta for the market is about 1. The reason we hold a number of securities is to diversify, okay? And you really can't do much with a portfolio that's diversified with a +1 correlation. But you can, if you start to move around the weights in the correlations, and get the correlation to change, okay? That's just two assets. We went through beta. We also went through figuring out the variance and standard deviation and return of the portfolios, okay? And how we kind of use diversification based on the number of securities we hold. And again, that old adage, hold more than one egg in the basket, right? So you can only diversify away so much risk. And then we get down to where the risk is really diminished away, diminishing returns in terms of diversification. Once you get past 15 to 20, more or less, okay? So with that said, I'm going to get into the problems here. We've already gone through that big long formula, which involves the variance and covariances of right here, okay? The variances and covariances, in fact, that's the portfolio variances right here, okay? And just so you guys got a heads up, I'm going to zoom in here real quick, all right? This part right here, okay, represents the covariance. This part right here represents the variance. That would be the variance of stock 1, the variance of stock 2, and its weight of each one that you hold. And then these X's represent the weights. That's the correlation. And these are the standard deviations, okay? So just a heads up, that's for two stocks or two holdings. And then, of course, that's the risk of the portfolio. The return is, again, just a weighted average, simple weighted average. Okay, and with that said, ladies and gentlemen, let's get into number one. All right, so number one, let's look at it. And I actually did the problems. Hold on just one sec. Number one, chapter 7, I promised it would be short, and it's going to be short, okay? This actually comes from when we were working with stocks back in chapter, I want to say chapter 7. What am I saying, chapter 7? Back in chapter, I know it wasn't chapter 5. It was actually chapter 5, I believe. Or chapter 4, I'm sorry. So chapter 4, when we were working with stocks, okay, the value of common stocks, we came up with a formula, and I'm going to show you this formula. So I'm doing number one right here. Says the rate of return, the level of Philadelphia market index is 21,000 at the start of the year. At the end of the year, it ends up being at a level of 25,500 at the end. The dividend yield, okay, on the index is 4.2%. What's the return on the index over the year? Okay, so that's 1A. B is if the interest rate is 6%, what is the risk premium over the year? And C is if the inflation rate is 8%, which is a good one. This is the Fisher effect, domestic, not the international version. What is the real return on the index over the year? Okay, and once I'm done with this, then we will go into chapter 8, just a real quick introduction, all right? So looking at this, you guys, there are two parts to this return. Let me see if I can write this out and if you guys can see it. Since I'm using my box, so to speak, okay, I'm going to work with this one. So in this case, our total return for number one, chapter 7, okay, page 191, okay, total return is going to be equal to our, in this case, we're going to be using an old formula, okay, and this formula is going to look something like our dividend yield, okay, which is dividend of the next time period, all right, over the price. This is R plus G, all right, and this was P0, all right. In this case, what we can do is, sometimes what we can do is, this is what we call dividend yield, okay? If they give it to you to where you have two components, and in this case we do, we have the index, and I'll kind of write this out for you and show you how we can put it together. We have, I'm going to change this. This would be dividend yield. This would be growth in any dividends. This is how we did it in chapter 4, okay, in dividends, all right? And this is the payoff in dividends, okay? This can also be used as capital gains, all right? And that's what we're looking at right now, capital gains. So this index, just like the S&P 500, except this is the Sildavia market index, okay? And in Sildavia, they speak Sildavian. Okay, so we've got our total return, okay, comprises basically if we sold it at the end, okay, or a share of it. And it was making 25,500, okay, which is the ending price, P end, over the beginning price, P0, which is at the beginning of the year was 21,000, okay, all over 21,000, okay, and this will be my capital gains. Do I get taxed on capital gains? I do, okay, at least here in the U.S. Now, with that said, this is an index. So in this case, our dividend yield, okay, so we have a index that also pays, in this case, dividends. So they must be selling shares of, just like they sell shares of the S&P 500. So in this case, we do have a G here, which actually stands for dividend yield, okay? So they're kind of used interchangeably, or dividend growth. In this case, it says dividend yield on the index is 4.2%. I'm going to flip these around. You can do this. It just depends on the context that you're using. So I'm going to use capital gains plus dividend yield, okay? And in this case, this ended up being 4.2%, okay? So if we calculated this, this is going to be our big R, okay? And this would give me about, and I wrote this down, I'm just going off my notes of what I did here, okay? And I got 4,500, okay? Difference of 4,500 over 21,000. That would tell me how much I made in terms of profit, if I did at all, in percentage. And that turns out to be, that's a pretty big profit. It turns out to be 0.2143. The book might have different, but this is the way I'm doing it. Okay? Our dividend yield is plus 0.0042. Okay, I always like to start off with dividends. And when we're working problems like when we're doing variance and things like that, I like to take it out to 6 or 7 decimal places. It just makes it easier to work with. So right here we've got 21.43%, okay, plus another 4.2%, okay, and that's going to give us about 25.73%, okay. Now, did I just, oh my gosh, I can't believe I did that. Okay, 6. So we've got 25.63% in terms of total return, all right? That's number one. Okay, that is part A. Part B says, if the inflation, watch me drop my cord here. The inflation, it says, if the interest rate is 6%, what is the risk premium? Okay, what is the risk premium over the year? All right. What they're talking about here is, since this is a, let me show you here, since this is a market index, okay, there is a risk of holding anything above the risk-free rate. And in this case, it says the interest rate is 6%. So I'm going to guess that they're talking about the risk-free rate. Okay, just like here in the U.S., where the risk-free rate or our rate that has the least amount of risk is a government bond. Okay, so in this case, when we figure out, and we'll be doing this in the next chapter with the capital asset pricing model, I'm going to use the risk-free rate is equal to 6%. Just work with me here, okay? So when we talk about a premium, it's a premium that investors pay over the going market rate. And so what this ends up being, just one sec. Again, oftentimes we'll see, just so you guys have a heads up, we'll see that, and this is going to come into chapter 8, but we're doing chapter 7 right now, number 1. We'll see that the risk premium, okay, I call it market risk premium, okay, premium, all right, any premium is just an extra charge that investors put on. All we're doing is taking the difference between the return on the market, in this case, the market index, which is this one right here, Soldavia, and we're going to take the difference between that and the risk or the less riskiest bond on the market, which in this case will be a treasury bond. So this is going to be 6%, okay, and we just figured out what the total return is. The total return for Soldavia was 25.63. So if I do 25.63% minus a 6%, this is going to give me my market risk premium. Okay, so it's what folks pay over the risk-free rate for basically investing in the market, but in terms of what they get in return, okay, in percentage. So this, in essence, I already calculated it out, should be about 19.63%. Let me double check. This will be 25.63 minus 6 equals 19.63%. Okay? Oftentimes, just so you got a heads up, we will see this. Can you guys see that? Let me zoom out. Okay? I'm going to be kneeling here. Oftentimes where we see this, and I know many of you are going to see this as very familiar, we will see this in the expected return, okay, of the CAPM model or the capital asset pricing model, which allows us to come up with like a discount rate where we can basically evaluate something. It allows us to value companies. It's a very handy tool, the capital asset pricing model, okay? And the formula for it is the risk-free rate, okay, plus, all right, then we've got a beta, all right, which is just that volatility of, market volatility of the certain stock, okay, or price sensitivity, times RM, which is the rate on the market or market index, which could be the S&P 500, in this case it's Soldavia, less the risk-free rate, okay? This gives us an expected rate which we can use to discount things with. We can use it to evaluate companies. There's all kinds of things you can do. You can use net present value. This is why we use often the capital asset pricing model, okay? It also allows us to value stocks in terms of, is it undervalued or overvalued, both in terms of percent and in terms of dollar price of its share price, okay, or dollar share price. All right, okay, part C. So if they ask you what the market risk premium would be, it would be 19.63%. Okay, part C for number 1, 7.1, or question number 1, chapter 7, part C, okay, is going to be where we add in the Fisher effect. And you guys remember that one. That is normally comes into play with bonds where we're talking interest rates. We're going to look at the effect of inflation on Soldavia. Okay, so if I had, again, if we had an inflation rate of 8%, okay, what's the real return? And your nominal return is always going to be quite a bit bigger than your real return, okay, on this index over the year. Okay, so in this case, I've got, I'm going to just use this formula, and this is called the Fisher effect formula, which is 1 plus big R, which is the nominal rate, okay, or whatever rate they quote, all right, equals 1 plus the real rate, okay, and 1 plus H. And the Fisher effect, okay, by Irving Fisher, okay, actually this is called the Fisher effect, and the reason is because it takes into account inflation, all right, and this is the real rate of return right here, real rate, all right, and this would be the nominal rate, like a rate quoted on your credit card, okay. In this case, what they're saying is if we use the total return and we got a rate back of, let's say, 1 plus 0.25, what did I say, 63? So the Soldavia market index, okay, return is equal to 25.63%, okay? So if we did this and set this up, we're going to solve for R. And when we do that, I have 1 plus the real rate of return, okay? So once we take into account inflation, which is in 1C of Chapter 7 on page 191, is 8%, okay? I'm going to end up with a much smaller rate than 25.63%, okay? 8% smaller, in essence. The way we do this is you just move this over here, and then you minus a 1 and solve for R. So this would be 1 plus 0.25. This is again C, number 1, okay? And CC, okay? And we'll move this to 1.08, all right? And this is going to be a minus, let's put little brackets on there, a minus 1, and this should give us our little r, which is our real rate of return, taking into account inflation, okay? And if I do that, that's going to give me, shame on me, I didn't do it, or I kind of did it. So this would be 1.2563 divided by 1.08. It's going to be about, and minus a 1. This should be a real return, okay, of about 16.324%. Okay, so 16.32%. Okay, and I don't know if that's right or not, but I'm hoping it is. We did it the correct way, and that's, as long as you show your work on your test, you're good. Okay, and so that should cover it. That's the real rate of return taking into account inflation. Okay, and of course we can use this many different ways. Another formula to be aware of that they use as approximation, okay, and they also use this to deflate and inflate time series of basically series of, let's say, for instance, balance sheet items, where you have it over, let's say, the past 10 years or 20 years. You can take into account inflation. It'll be much more accurate. So when you're dealing with this, and businesses also use this, this is the approximation of the Fisher effect, okay? And so you can get a real quick idea. And if you do this, if we were doing this one right here, we would just do R equals big R minus H, okay? And in this case, this would be 25.63 minus 8%, okay? And that's going to give us about, let's see how different it is, 25.63% minus 8 equals a little different, 17.63, okay? So again, it's an approximation, okay? It should be somewhat close, but it can also be somewhat different too. And again, that's a little different. Okay, double check my figures just to make sure that I was on the right track, and yes, that's it. So if you look at this, it's getting hot in this room. If you look at this, this is the accurate way to do it. This is the approximation way of using the Fisher effect for part C of number 1 in chapter 7. Okay, that's the end of that problem. So end number 1. All right. Okay, you guys. So let's get ready to do number 2 for chapter 7. And when we're doing it, we are going to look at my glasses on here. Trying to stay away from headaches. So in number 2 in chapter 7, looking at this, we're going to be doing the Costaguana stock market provided a real rate of, provided a rate of return of 95%. Let's have high inflation. The inflation rate in Costaguana during the year was 80%. In Ruritania, the stock market return was 12%, but the inflation rate was only 2%. Which country's stock market provided the higher real rate of return? So again, this is kind of the purpose of why we use the Fisher effect. And in this case, we're using what they call not the international Fisher effect, but what they would call the domestic Fisher effect, okay? So in this case, let's go ahead and go through this. This would be, again, I've worked the problems out. And what I did was, I promised I would try and keep it short, okay? Let me zoom out a little bit. Hoping you can still see that. So in Costaguana, we've got a market rate of 95%, or 0.95. We have an inflation rate of 0.85. And remember that really what we're doing here is we're using the approximation or at least the 3 components of the Fisher effect, the nominal quoted return, okay, which would be this, all right? Since it is mentioned in there, they just go off and they say, okay, the Costaguana stock market provided a rate of 95%. That would be a nominal rate of return. It's stated or quoted. And then in this case, they give us inflation. Then in Ruritania, we've got the inflation is 85%. In Ruritania, we have a 12% return on the market, and yet they only have an inflation rate of 2%. So proportionally, they're about the same, but are they? So the way we can do this is by solving, this would be the big R, this would be the H, the big R, okay? And what we're going to do is we're going to solve for the little r, or the real rate of return, okay? Using, again, the formula we just went through and did for part C of number 1, okay? Right there. So with that, let's flip it over. Where'd it go? And let me find my problem. Just 1 second. The right way. So in this case, I just wrote this up And based on, they're asking which real rate of return is higher, either the Costa Guana market or the Ruritanian market for number 2 in Chapter 7. And just looking at this, I don't have solutions close by me, but I'm just going to play it by ear. Divided by 1.85 equals, so we've got about a real rate of return of 5.405, taking into account inflation, and they have a much higher rate of inflation, okay? The next one is 1.12 divided by 1.02 is actually 9, it's a little deceiving, 9.804, okay? Not deceiving, but they look very similar in terms of proportions, but the one who has the higher real rate of return, which is the one that counts, taking into account inflation, is going to be Ruritania, who has they're making 12% on their market index, and yet they've got a 2% inflation rate, okay? Not far behind them is Costa Guana with the 5.405%, and this is the real rate of return. Again, this is using the Fisher effect, okay? In this book, they'll talk about a lot about, what is it? The real rate versus nominal rate, inflation. Okay, so that is the end of number 2 end, okay? And I believe I said, and I'm probably going to get this wrong, and get a lot of people saying, no, you didn't assign that one, okay? So let's just go through this for the heck of it. How about number 9? So number 9 is average returns and standard deviations, which actually is a pretty good exercise given the fact that, and let me see if I can zoom in here just a bit, given the fact that we're dealing with a mutual fund manager here, actually make believe, but it's still pretty good, or yeah, she's got Ms. Soros as a mutual fund, and you never know, she might have an ETF as well. Okay, so during the boom years, 2010 to 2014, Ace Mutual Fund manager Diana Soros, number 9 in Chapter 7, produced the following percentage rates of return. Rates of return on the market are given for comparison, okay? And so we're looking at her, and this is pretty similar to actually what they do. Yet we also look at the S&P 500 and use that as a benchmark to see how well she's doing, okay? Calculate the average return and volatility or risk, standard deviation of Ms. Soros' mutual fund. How did she do? Did she do better or worse than the market by these measures, okay? And by average return, they're talking about just the mean. And what I was going to explain, just in case you're wondering, with number 9, when we do, like say for the portfolios, in this case, we're not really doing that. We're just looking at returns. You can use a geometric average, but in this case, what I was going to say was when we've got, hold on one second, I just blanked. Anyway, let's go through this, do the average return, and then we'll look at the S&P 500. So to do this, it's really critical before you get the variance and then standard deviation. The nice thing about using standard deviation and average return is they're both in percents. The one thing I was going to say was when you're doing your variances and standard deviations, especially variance, if you're forecasting, it's good to use the formula just as you would if you were taking a sample of the population. So if we're using historical returns, we're going to use the whole population. So we're not going to use the n minus 1, we're going to use the n, okay, in the denominator, all right, for variance. All right, so with that said, let's go into number 9. And actually number 9, I did calculate it out. I was out at school, they turned off the air. So I stuck down around there about 2.5 hours or so. And then I said, okay, we better get out of here. Doing a little of both classes here. Okay, so with this one, what I did was actually, I set this up in a similar manner, okay, because we want to find out, first of all, who did, let me zoom back out, let's zoom back out. I'm hoping you guys will be able to zoom in once I put this into Camtasia, okay. That's the nice thing I'm learning about Zoom. They do it all for you, somewhat. So Ms. Soros makes in 2010, right off the bat, she's making 24%. Then she has a rough year. She's down 9%, up 18.6. Then in 2013, she's making 42.1, very good, 15.2%, versus the S&P 500. So she's outdoing the S&P 500 quite a bit in year 2010, yet she underperforms S&P in 2011. She outperforms in 2012, in 2013, and it looks like she even outperforms in 2014. So let's see what's going on here. We've got all positives. We have one negative here, a negative 9%. And again, all I'm doing is I just rewrote these returns right here. Okay, so to get the variance and standard deviation, you first want to calculate your average return. You're going to need those. So what I did was, let's start off with the S&P 500, and then we'll come back to Ms. Soros. Okay, so what I did was, I basically calculated the S&P 500, taking the 5 returns, okay, and took the average. All right, they're all positive with a 17.2%. And notice I put a 0 out in front, usually, especially when I'm doing variances. Again, there is a calculator that will do this on the web for you very quickly. Obviously, you can do this on Excel very quickly. This isn't the only way to do it, but it never hurts to do it by hand, especially like when you're working with portfolio calculations, not necessarily in this instance. So when I did this, I got an average, and that is a point right there. And let me see if I can zoom in just a little bit. Okay, so we got an average where I got the average of the S&P was 16.02, okay? And that's divided by 5 returns, okay, across 5 years. And looking at this, then I took the variance, okay, which is just another form of volatility for the S&P. And what I did was, again, we're just taking, I got the average or the mean, okay, 16.02. And so I take the first year, okay, 2010, which was 17.2. So I take that 17.2 or 0.172 minus a 16.02, which is the average return. Okay, and again, this is how we get the variance, and then you square it, all right? And so what I did was I did them vertically and then put the numbers over here. I put them up, they're off by 1. So actually, this goes down here. This one goes down here. This one is virtually, unless you're running out 6 to 7 decimal spots, you're going to get a 0 on this one. So basically, when I totaled them up, after doing this, I ended up with about 0.0525, okay, which is about 5.25%, okay, divided by 5, not the n minus 1, but the 5, or the n. And I ended up with a variance of roughly around 1.05%, which isn't much. So not much volatility there. However, when we actually, I took the square root and I got the standard deviation of about 10.293%, okay? And again, the problem calls for, let's see, calculate standard deviation. So it does ask for that. So 10.293% is our standard deviation, okay? And the return was 16.02%, okay? 2. And so in this case, we've got a return on the S&P 500 of 16.02, and we've got a standard deviation, which actually is, even though I said that wasn't much, it actually is. Standard deviation of 10.293, relatively speaking, that's pretty big. But in this case, it is the benchmark. Now, how does that compare to Miss Soros? Okay, so we've got return, we've got risk. All right, so, and I went through 3 parts there. I went through the average return, the variance, and then I took the square root and got the standard deviation, okay, which is 10.293%. Okay, so when I did Miss Soros, what I did was I went through it, and some people do it differently. They might change it around and use the percentages. I find it easier to do it this way, at least if you're going to do it by hand. So what I got was, for an average return, I got 19.98%, okay? And I was using about 5 decimal spots. Then what I did was I took each year's return, okay, that she made, and I'm looking, she made 24.9% in her fund on 2010, or in 2010. So what we do is we take that 24.9% minus her average return, or mean, and then square it, okay? And when we do this, when we do this, we end up with, again, I'm going to divide by 5, and I work through it. Actually, there's a minus in here. We've got a minus, roughly, what is that? That is, thanks, Sean, okay, that is a minus 0.9%, okay? So, minus 0.9% minus a positive 19.98%, okay? So she did pretty good. Her return was better than the S&P 500, but how was her risk? So the variance ends up being, when I do this, I ended up with about, I want to say, point, and this is because I was using only several decimal spots, 0.0020, okay? In the text, I believe they got 0.019485, okay? Which is, that should be the variance, okay? So when you take the standard deviation of that, and I'll double check right now, we should get about 13.96%. So let's see what we got. Let's double check that. If we did 13.96, squared it, okay, 19485, 19488. So in this case, if I took the square root of 0.0020, okay, that will give me, it's off a little bit. Let me double check that number. Give me 1 second. Let me check what's the answers? Let's see what I did. Did something, oh, I see what it is. Okay, so on then number 9, just double checking here. Number 9, we got a variance for Ms. Soros of 0.019485, okay, or 0.0194, all right? And if we do that, that's about right. So if I take, and that's how I got it, okay? And you can see that the calculator rounded it here. This is actually the answer once you take into account at least 6 decimal spots. In this case, I'm going to use this number and square it. So if we do this, this would be 0.019485, okay, and square root, which gives me about 13.959 or 13.96%. So she made, she did good. She got a 19.98% average return. And average R, okay? And her standard deviation was 13.96%, okay? So again, this number is really critical if you're going to calculate variance and standard deviation. And I believe on the S&P, the benchmark for the market, we got a 16.02, and we had a variance, or excuse me, a standard deviation of 2.93, so 10.293%. Okay, so not bad. I mean, she came out with a higher return, but she also came out with higher risk, which is normal. Okay, so did she outperform the market? Yes, she did, but she also had a riskier, somewhat riskier mutual fund. Okay, so that is the end of number 9. End. Okay. As for number 23 in chapter 7, number 23, what we are using, did I just do that? Number 23. That's one of the problems I gave you. It says a portfolio contains equal investments in 10 stocks. Okay. And remember, beta is just a measure of systemic volatility, or systematic. I can't believe I said systemic. Systematic, which is the market risk of each stock, the market risk component. And in this case, portfolio contains equal investments in 10 stocks. 5 have a beta of, I'm reading the problem, 1.2, and the remainder have a beta of 1.4. What is a portfolio beta? In this case, you can just take a weighted average, just like you can in terms of average returns, okay? So in this case, we're looking at the volatility of the beta, volatility of the portfolios, okay? And in this case, we are looking at one portfolio with multiple stocks. So we're looking at kind of it's basically the average beta per se. So we use a weighted average measure. And it says 10 stocks, okay? So 5 of those stocks, 5, okay, have a beta of 1.2, okay? So I remember the beta of the market. Beta, again, is just the covariance of the stock and the market, okay? And don't let this fool you. This is actually a different, this isn't just regular standard deviation. And over the variance of the market, okay? So when we look at something like this, the beta in the market is thought to be right around 1, okay? So if you have anything larger than 1, say 1.2, it's considered more volatile than the market. So these 5 stocks are more volatile than the general market, okay? So I would say, okay, 5 of those have a beta of 1.2. The other 5 Okay, 10 minus 5. This is how I would do it. Have a beta of 1.4. Okay, even more volatile. All right. And I would take this and divide it by the number of stocks. And this is going to give us that, just basically, again, a weighted average of the beta of this portfolio. Okay. And when we do this, this should give us about, let me see here, this is 5 times, we've obviously got a pretty volatile portfolio. Hopefully it's making a good return. Doesn't tell us. 5 times 1.2, okay, and that is 6.00 plus 5 times 1.4, which is 7, okay, and which gives us about 13 divided by 10, which should be about a beta of 1.3, okay, a beta for the portfolio. All right, and the question says, what is the portfolio beta? Is it 1.3, greater than 1.3 because the portfolio is not completely diversified? Or is it less than 1.3 because diversification reduces beta? In this case, diversification does not reduce beta, okay? The one thing that does reduce beta is working with its correlations, working with its correlations and its weights, okay? When you're talking beta, you're just talking the market risk, and that's it. You can't really diversify that away. You can hold different stocks with different betas, though, all right? And that will get you at least a portfolio that moves all together against or with the market to a lesser or greater extent. So again, answer B is greater than 1.3 because the portfolio is not completely diversified. You really can't say that. It is 1.3, okay? So that is the answer for number 23 in Chapter 7. All right. Now, I'm going to go back to number, let's see, what was it? 20, real quick. And I don't remember if I told you guys to do 20 or not, but I thought I would just go briefly through it. Let me pull it up here. And this has to do, and then I'll do 13 and 14 real fast. Okay. Number 20, let me see if you guys can see that. As you can see, I've written all over it. Okay. Number 20 is, and I can't even say that, hyacinth, okay? I know I'm totally mispronouncing that. Macaw, okay? Mr. Macaw invests 60% of, it's a her, 60% of her funds in stock I and the balance in stock J. The standard deviation of the returns on I is 10%, on J is 20%. Okay, so J is obviously a little riskier. Calculate the variance and standard deviation of this portfolio's returns. Okay, and again, that's an important point to remember, is when we do the variance and standard deviation, we are assuming that we've already got the information on the returns. Otherwise, you can't calculate the variance. Now, it says, how is the portfolio standard deviation and variance going to play out if you have different returns, okay, or different correlations, okay, between I and J. So what I did, and this is number 20, let's see if I can find it here. What I did was I actually, let me see here, here it is, found it, okay. So what I did was I used our typical portfolio variance formula, okay, which is again the variance of portfolio. It's pretty good to know because in terms of, again, it's very important in terms of being able to judge the risk of a portfolio. It's based on the returns. In this case, it's just 2 assets, okay? And you can go right on the web and find a portfolio variance calculator that will do it for you very quickly. In fact, I think I've shown that to you there on in one of our past classes, okay? So what I did was I did the same formula. I said, what's the weight of stock I, okay? In this case, it's 60%, okay? And the standard deviation or variance, so I'm going to take, if I know the variance is, in this case, give me 1 second, let me double check my answer. Yeah, standard deviation of returns, okay? So in this case, I'm going to take, I just want to make sure I did the right thing. Hold on 1 second. So when we're looking at this, you guys, we're just going to use our typical formula that we use. Okay, so we are on number 20. And number 20, and this was extra, I believe. And remember, we had weights in the portfolio, only 2 assets. One was 60% with stock I, one with stock J of 40% of the portfolio. And stock J actually was more volatile with standard deviation of 20%. Stock I had less volatility with 10%. And it says, what is going to be the variance in standard deviation of this 2-asset portfolio if you use a correlation of 1 versus 0.5 versus 0, okay? And I don't know if you guys have noticed, but in the PowerPoints, they talk about weighted average in PowerPoints, in the portfolio variance calculation. And that's if you were to use a weighted average. And there's really no such thing as a weighted average in portfolio variance. You have to kind of follow this formula. So again, what's the formula? The formula is, if we're doing this, would be times the standard deviation of I, okay, which is 10%, all right, and everything is squared, okay, and they're multiplied, all right, and so this would be 0.60 squared, okay, we have 60% of stock I, and standard deviation based off the returns is 10%. Square that gives you the variance, okay? And you take that component. This is the variance of stock I. That's that component of the portfolio. And if you're doing this for the whole standard deviation or variance of the portfolio, this is how you calculate it. And then you would do the weight of stock J times the standard deviation of J, and then you square it, that makes it the variance, okay, again, and then you're going to do the covariance, which is 2 of them, and that would be the weight of I times the weight of J, stock J, in the portfolio, times whatever portfolio, the correlation between I and J. Okay, this would be the Pearson correlation coefficient, most likely, I and J, all right, times the standard deviation of I times the standard deviation of J, all right, and they call this the covariance portion, okay? So again, this is how you do it. I actually went through and did it for each one, all right, and let me just pull my red pen out here so you guys can see what I did. So it's saying, with the correlation changing, okay, here, here, and here, how does that affect the standard deviation of this portfolio and its variance, okay? And again, this is only 2 assets. So what I do is I calculated the first part without using one of the web calcs, calculated the second part, the 40% of stock J. And then together with that, let me see what I got right here. I calculated them right here. Okay. We get the variance. I'm working with variances here. Okay. I add them together and I get 0.0100. All right. Then what I do is I say, okay, well, if I did a correlation of 1, that's not diversified. Okay. So what is that going to give me? That will give me my highest level of standard deviation. So it's important to kind of note that. So what I did was I calculated the covariance section based on the 1 for correlation, positive 1.0, okay, a 0.5, and a 0 correlation, okay, to see what would happen to it. And I ended up with calculating this across. That's why this number is here, 0.00960, okay, plus the 0.0100, which is just the variances of each portfolio. And then I added them together, okay, and I ended up with a covariance, okay, of, a variance of 0.0196 with the perfect 1 correlation between I and J, okay, which gives me a standard deviation of about 14%. All right. Then I went down and I did this again for the 5, the correlation coefficient of 5, and I got a variance of 0.0148, a little smaller volatility there. Okay, and that gave me a standard deviation where I just take the square root of this, and that gave me about 12.1%. Okay, so that's still a positive half, okay, for a correlation coefficient. Then I get down to 0, and when we times this out or multiply this out, 0.6, 0.4, this is what I hold of I in stock J, times 2, times the correlation coefficient, then times the standard deviation of I and J, okay? But if it's times 0, everything is zeroed out. And that's actually where you end up getting a weighted average, because all you get is these two components right there, and everything else is zeroed out if you have a correlation coefficient of 0. And that gave me a 10%, and it gave me a variance of, gosh, what was that? It gave me a portfolio variance of 0.0100, basically 1%, but I can't say 1%. And so I took the square root of that, and it gave me about 10%. So we went from a 0 correlation factor between I and J in this portfolio, and it gave us a volatility or standard deviation of 10%. And we went with the highest correlation coefficient, and it gave us a standard deviation of 14%. Okay, so a much higher risk. So as you can see, when there's no diversification, the risk is higher. You can diversify away a lot of that risk just by lowering down basically what you hold and the weights that you hold. Okay, and that allows you to diversify away that unique or unsystematic risk, not the market risk. So the market risk you can't really diversify. Okay, the market risk is something such as a crash due to systems. So that's, and again, this is number 20. Okay, so just a heads up, I went through that. And let's see what else we did. We did number 14 and number 13. I'm not sure if I give you guys 14 and 20, but I'm just going to review it anyway, or 13. So in 13, we are doing right here hopefully you can see that. Let's flip it around here a little bit. Okay. So it says risk and diversification, in which of the following situations would you get a larger reduction in risk by spreading your investment across two stocks? The two shares are perfectly correlated. In that case, you can't do much about diversification. There's no correlation, okay? That doesn't help us out much. There is modest negative correlation, or there's perfect negative correlation. So in which case would you get the largest reduction? So if there's no correlation, you get some diversification. Negative, some. If it was a perfect -1, you would get the most diversification benefit and reduction in risk, okay, in standard deviation. That's how to answer 13. Number 14, I think it's pretty important just for the concepts behind it. Number 14 says true, false. Investors prefer diversified companies because they are less risky. Okay, actually, they prefer investors prefer diversified portfolios. You can't really diversify the company. All right, you can the portfolio. That's where they're coming. At least that's where they're coming from. Okay, if stocks were perfectly positively correlated, diversification would not reduce risk. That's true. That's why you have to change around what you hold to get a different correlation. Diversification over a large number of assets completely eliminates risk. Is that true? No, there's actually two components, right? There's the unique part, and then there's, or the unique risk, specific risk, which is standard deviation. Then there's beta. They're both volatility measures, and beta is in terms of price sensitivity to the market, or how the share moves along with the market. So in this case, it says diversification over a large number of assets completely eliminates risk. False. Okay, it does not eliminate market risk. And we're talking total risk here. Diversification works only when assets are uncorrelated. For the most part, in this case, that would be when they're uncorrelated? No. What they mean is when the assets are uncorrelated or zero, or -1. Now it'd be zero, which is false. Okay, hold on one second. So let's go through this, just kind of reviewing how we're doing all this, and this acts as a good review to the chapter. E, diversification reduces, and again, this number 14 from chapter 7, diversification reduces the portfolio beta. Diversification actually reduces the standard deviation of portfolio. Beta has to do with market risk. Okay. And in this case, F, a portfolio of stocks, each with a beta of 1, okay, will have a beta of less than 1 unless the returns are perfectly correlated. Okay. And we know that if we do this, we're going to use, if we were doing this, we had multiple stocks in a portfolio, we would get basically, so again, think of it this way. It's sometimes not the easiest thing to explain. Diversification works via correlation, okay, but it does not work through beta. So you might be able to get the weighted average, and that's about it. You can change around the betas due to changing around what you hold. A stock with a low standard deviation always contributes less to portfolio risk than a stock with a higher standard deviation. In this case, what they're saying is a stock with, you could do the opposite. A stock, if we're looking at total risk here, to portfolio risk, they would be saying total risk. So in this case, this is only one part of the risk, standard deviation. So you'd have to consider the market risk or the beta as well. Okay, so it would be false. The contribution of the stock to the risk of a well-diversified portfolio depends on its market risk. Okay, in this case, the contribution of the stock to the risk of a well-diversified portfolio depends on its market risk. In this case, we would look at it, and this would be contribution of the stock. It would be standard deviation. Okay, not the market risk, but the standard deviation. So again, this is all about, they're just throwing different ones out to try and trick us. This standard deviation in terms of diversifying and reducing the risk of the portfolio. So it doesn't have to do with market risk. So that's not true. Okay, so in this case, a well-diversified portfolio with a beta of 2 is twice as risky as a market portfolio. That's true, okay? Because we know the beta of the market is 1. An undiversified portfolio with a beta of 2 is less than twice as risky as the market portfolio, okay? And on that one, I would say if you've got a diversified portfolio, we assess basically market risk, okay? So if you have an undiversified portfolio, that means you have some diversification still left. So in this case, I would say false. And just looking at what they said, you still got to deal with your diversification and specific risk or standard deviation. And then look at the betas of each stock and how it combines into your portfolio. Okay, so I would say false. Okay, and that is pretty much it for chapter 7. All right, we're going to go into a little intro into 8, and we're going to get you guys going here. Good job. Okay, one sec. Okay, you guys, let's start to go into chapter 8. And I believe I already signed the homework, but I'm just going to go over a couple things. I wanted to go over, I'm going to give you just a couple of, probably 2 extra problems. Not because I want to add extra to you, do it only if you can, okay? And with that, as I go through this, I'm just looking at the problems I picked. If we could do 2, 3 is extra, 9 is extra, but 2, 6, 11, and 15, okay? The efficient portfolio, actually where you plot out an efficient portfolio, okay, and I'll talk about this in a minute. 6 is really important. 9, Sharpe Ratio is basically return to risk. It's a very handy ratio. Number 11 is the beta, okay? And the beta, 40%, okay. Would you invest in? Okay, and this is a pretty good one. Number 11, if you can do it, if you have time. And number 15 is regarding the capital asset pricing model. Very, very useful, okay. In this case, the expected return, we need to recalculate using the capital asset pricing model formula with the beta of 0.8 and see if it comes out, gives you an expected return which is bigger than, or return costed. You know, you can use the CAPM in 2 different ways. You can get a required return or discount rate, and you can compare it to the expected return. In this case, that's what they're talking about. So you just recalculate using the CAPM, using a beta of 0.8, and see if you get an R, which is greater than the expected return. If you don't, you have a negative NPV. If it's under the expected return, then you have a positive NPV. That's kind of how this works. They can be very confusing problems, but I think that's a pretty good question. okay, and 15, and I believe that's it. I just wanted to quickly go through the PowerPoint very fast because I think we're going to get a lot more out of the problems. But I will go through just the essence of where the modern portfolio theory came from, so to speak. And as I promised, I'm going to try and keep this short. Okay, let me close this. And let's get this rock and roll. Okay, one of the things you're going to see these guys touch upon quite a bit is Harry Markowitz, which is 1952, okay, came up with the idea of the modern portfolio, what we call the modern portfolio theory, okay, and apart from that, he didn't do it alone. He was working with James Tobin, famous for Tobin's Q, which is the value of a company. Also, William Sharpe, we'll call him Will, okay, Sharpe, who is famous for deriving the capital asset pricing model in the 1960s, okay, and Milton Merton. They actually won the Nobel Prize. Believe it or not, what he derived and what we're looking at in terms of diversification and things like that still apply today. There's some competing models out there, especially for deriving the expected return or your discount rate, however you choose to use the capital asset pricing model. This does allow you to price in terms of the rate, your return on an investment, on a stock, on a project. And it also allows you to derive the discounted value, among other things, also the NPV. So it's a very valuable tool. And there are also some competing theories, okay? This is based on something they call the security market line, okay? And this one right here, there are some other theories that you're going to see talked about in here. Just be aware of them. One is there are a couple of three-factor models as things start to progress. Three-factor, you guys might have heard of one of them called the Fama and French model, okay? And what they did was Fama and French, I'm probably going to get this wrong, 1992, brought about basically the idea that you've got your capital asset pricing model, okay, which is the expected return, okay. This is how you can or determine whether a stock is under or overvalued using the CAPM. And this is the one where it talks about the risk-free rate, which is like a T-bill or T-bond, not a T-bond, a T-bill, short-term, plus the beta of a stock, okay? And this is for, let's say we're pricing one individual asset times the market return minus the risk-free rate. And what these guys, Fama and French, did was they added on a couple factors. That's why they call it the three-factor model. This is one factor. And then they added on where theirs was, they also took into account another beta, and they called it beta 2, in this case, or beta, you could say beta S, okay, which had to do with large versus small companies, okay? And then they also had another one in there that was based on value, okay? Which was, you might call it high minus low, okay, which is taking into account different sectors and value shares, okay? So ones that are higher price versus low price, ones that are large size versus small size. And they would take the difference and include that in the beta. Now, those are getting into a little more sophisticated models. Another one that you guys have heard of is APT, or the Arbitrage Pricing Model by Stephen Roll. Okay, and that's another good one. He actually takes into account not just the CAPM, but also, in addition, actually doesn't even use the CAPM. But what he does is he includes, I believe it's back here. The only reason I'm talking about this is if you end up talking to somebody who works in finance, it never hurts to know. Actually, Stephen Roll took into account, and it is based on arbitrage pricing and taking advantage of arbitrage. So the law of one price. And if you have the same asset, but one's, let's say, a bar of soap was priced differently in Philippines versus Japan, you can quickly take advantage of that in the market. And especially if we're talking shares, right? What he did was he included macroeconomic factors along with the rest. So you might have, the first one might be based on the interest rate, the next one might be on the yield, and so on and so forth. And then you have some that are involved with the market as well. Okay, so just a couple, and there's even a fourth factor. It's called the Carhart model. Okay, so with this, I just wanted to go through, let me zoom this out. I'm going to be very short with this. And again, the homework is going to be numbers, and I also gave you guys this. Hold on one second. The homework is going to be 2, 3, 6, 9, 11, and 15 if you can. All right? Do the best you can. You guys, in looking at this, I also gave you a supplement for this the other day through the email, which is basically the capital allocation line versus the capital market line versus the securities market line. Okay, and the little differences between them. But before I do that, and I'm actually going to use my own version, let's go into, we've already gone through diversification, so I'm not going to go much into that. Let's start to talk about risk and return, okay? I'm going to pass up on this right now because I'm going to come back to it. You guys, again, I talked about normal distribution and probability, okay? You know, the nice thing about it is you're able to discuss about, based on historical returns, whether a stock tends to be a little more risky or not, dependent on, okay, you can say within one standard deviation or 68% surrounding the mean, you can say that most of the time, well, you can put it this way, the fatter those tails become, the more risk there is of a stock becoming more volatile, okay? The closer it is tucked in around the mean, the less risky it's going to be. And again, normally you draw a trend line in there, and that's a very, very big generalization. You can also use normal distribution for forming your portfolios as well, okay? A lot of people use what they call the efficient portfolio curve. So with that said, and that's kind of what I'm going through right here, is the idea of kind of keeping to a less risky stock, okay, versus its expected return. Okay, let's look at this. Before we get in, I'm just looking to see if there's anything, because I'm going to show you guys my own version of this. We've got efficient portfolio, which is the Modertn Portfolio Theory. Okay, and let's see, we've got this, which I'm going to touch on right now. Okay, lending versus borrowing, which is figure 8.5. And then it goes into an example of using diversification. And here's where we have that weighted average that they were talking about. This only holds true if there's zero correlation, okay? Correlation factor here is a positive 0.19, okay? Not a perfect 1, but a positive 1.9, or 0.19, excuse me. So again, there is some diversification in here. or at least opportunity. Okay, so with this said, and the only time again that this where the standard deviation of portfolio turns out to be the same as the weighted average or just those first two components is when its correlation is 0. Okay, and just a heads up on that. If you want to go through that, that's cool. It's all about maximizing the return, increasing the risk. And I'm actually going to go back through this, but let me go through what I'm going to do right now. And I think it'll make it a little more, hopefully, a little more sensible. And in the end, we're able to use the capital pricing model, capital asset pricing model, to under or overvalue stocks and determine which is which. Okay, so let's get to it. I'm going to do that. And again, remember the supplement that I gave you, okay? What I'm going to do is, before I even get there, just remember, if you could, that as I draw this out, okay, this is actually in our book, and I believe it's anyway, this is about the changing if we have one stock versus another. Or in this case, if you had stock A and stock B, okay, you're going to look at the correlation. Correlation isn't the only thing that changes diversification. Also, the weight or the amount that you hold within. This would be a 2-asset portfolio. So you can see that if I just tell, let's say this was 100% stocks, which is considered the most risky, and 100% bonds was considered the least risky. At least this is the going view over many years. We're going to, just one second, go back briefly through the PowerPoint, but I think this is going to make a little more sense. You guys, this is just saying that, you know, the curve, so to speak, of how each asset combines in a portfolio, depending on its correlation. If you have a straight line, if these were two stocks and not stocks and bonds, you'd have a perfect 1 correlation if it was a straight line. It might look like a little less curvy, would be a perfect 0 correlation. And a perfect -1 would be something like this, okay? Where this is return and this is risk. Okay, but if we were dealing with 100% stocks and 100% versus 100% bonds, and we had a choice to make, you know, actually for years, and before I get into that, let me just back up a sec. Looking at this, you can see where stocks would be the riskiest. Let me zoom in, so to speak. The stocks would be the riskiest, so to speak. Stocks would be the riskiest. And you would come out here and draw your line down, okay, versus bonds, okay, which are thought to be somewhat less risky, okay. That's not always the case, but good quality bonds. If you were to hold a little of each, actually that reduces your risk even more. And that's where the magic of diversification comes in. Now, let me ask you one question real quick. If I had return here, R, and I had risk here, let's say it's standard deviation, okay, which means that I'm dealing with unique risk, okay, not beta, which comes in a different place. Let's just use, they're both volatility measures. If I was to shoot for, let's say, if I had a stock that was over here, this would be a little more risky, right? Yet it might have, I'm just going to make these numbers up, this might have about 18% in terms of standard deviation, so it's a wild volatile, and might only get about 6% in return. Okay, so obviously the goal is you want to go up into which quadrants of these 4. would be up towards the top left, right? And so that's kind of, in essence, in very short, that's kind of where the efficient portfolio model starts to come into play, where when you start to hold combinations of assets, you want to end up with a total return that gets you not over here, but over here as close to this line as you can get. Now, let me explain a little more. Knowing that our goal is to get as much return as we can while reducing the risk. Because again, if we look down here, if we move from here to here, we have reduced our risk quite a bit, okay? And increased, or at least kept the same in return, okay? So now let's think about, let's go back about 50 years in terms of the market, okay? Nowadays they're using artificial intelligence, neural networks, and regression, and a whole bunch of other things. But if you guys remember, there is a, besides the Sharpe Ratio, okay, which is after William Sharpe, who also developed the CAPM. And again, this is return, okay, over risk, in essence, okay. But before I get there, I want to go over this one, which is, it's got this, where we have this risk-free rate right here, lending and borrowing, okay. Now, what is this, okay? Well, let's start over here. Let's first start with this. I'm going to make up a little story here. And let's say that back about 50 years ago, they thought that, well, if you just hold, you can hold one or the other. You can hold stocks, which is the most riskiest, or did I just say most riskiest? Que lleva el más riesgo. Okay, so if you have the least risky and the most risky, least risky being 100% bonds, you can go somewhere in between, okay? But in this case, this is a perfect positive one correlation right here, okay? Between if you hold one bond and one stock. But let's say that we started to combine, okay? And let's say that we started to basically form, let's say 25% stocks, 75% bonds. That might get us over to a spot like right here, where I have return here and risk here. On the bottom, I actually have standard deviation, okay? And just like a beta of the market is thought to be 1, the beta, the standard deviation of the market is thought to be about 20%. The return on the market historically has been more or less 12%. And now, if I did this, this would be about combining a little of the bonds and a little of the stocks to reduce my risk, to move from this point or this point over here where I'm very risky, okay, and to move all the way into basically to a minimum variance and to where I have a maximum return, okay. Now, I could actually kind of move my way up this curve by holding more stock. So I could increase my stock holdings in my portfolio by 50%, or excuse me, by 25%. So if I held 50-50, in fact, we could even think about, since we're kind of trying to maximize that return, of maximizing, now we've maximized the return, and if you look at the person who holds 100% bonds, it wouldn't be the wisest thing to hold 100% bonds when you could hold 50-50, 50% stocks, 50% bonds, okay? And so this is kind of the intuition that is built up over the past 50 years. And so if we look at this, along came basically Harry Markowitz, who invented the efficient frontier. And he said, if you form a portfolio and try and get as close to these points as possible, we could call this the efficient frontier, where this would be the minimum variance. And it wouldn't be too smart to invest in a portfolio that brought you a return and risk at this point, okay? In fact, we could use the Sharpe Ratio to combine right here, where this would be, and if we had the Sharpe Ratio over here, let me show you real quick. So, Mr. Sharpe, William. Let me show you, if we took, and basically what they said was, if we introduced, and this is in the supplement, if we introduced a risk-free rate, let's say a treasury bond, that's making, now it makes about 0.02% or about 2%, 1%, 3% in that range. Even though it's gotten close to zero, it normally is in the range of about 2%, 3%, and that's a 3-month bond. And we normally think of a risk-free rate as having a beta of about 0, okay? So it is risk-free, okay? If we draw a line tangent to that optimal portfolio, that actually becomes what we call the equilibrium point, where we could say that this represents all portfolios in a market and the optimal spot to be at. Okay, so I'm going to call this M for market. All right, not a very good looking M there. Where they talk about lending and borrowing, and this is kind of what they built on, and there is actually a video on it in Chapter 8. And again, this is Chapter 8, you guys. They talk about the fact that you can surpass this efficient frontier by actually going out and borrowing using the treasury bills, okay, at a risk-free rate, and putting all your money into a position that would allow you to go and make a return that's even higher. Of course, it's going to be riskier. Okay, and that's kind of what they're talking about here. So when they're talking about borrowing, they're talking about investing in treasuries. When they're talking about lending, they're talking about, let's say, borrowing at a very low rate and going, let's say, on margin, and then borrowing stock on margin or lending, so to speak, your money out and investing in stocks of higher return but yet higher risk. And so this would get you out past the efficient frontier into this area. And they call this line that combines the risk-free rate and is tangent to the market portfolio, the best spot to be, the optimal spot to be. They call this the capital market line, okay? And this was derived by Markowitz, okay? And the cool thing about this is they use one volatility measure, and that's called standard deviation right at the bottom. And the way you can tell the difference between the two different ones, or at least the two very similar looking graphs, is you have return here, and I'll give you a different one that uses William Sharpe's version. You have risk, okay? And in this case, the formula for this, as I was drawing this out, the formula for the capital market line, okay, just so you get an idea of holding that portfolio somewhere along the lines, is the risk-free rate plus the standard deviation of the portfolio over the market. Okay, this would be like the S&P 500 rate of return, okay, less the risk-free rate over the standard deviation of the market, okay? And this will give you, basically, this is the slope, and this is where they get the Sharpe ratio. Now, with that said, if we did the same thing right here, and we took this down, okay, and now let's say we're at the market, okay, and we've got the market, we're at a perfect 50-50, and we basically made as much return as we're going to get for the risk. What I can do is I can also introduce the risk-free rate down here. Okay, that makes about, let's say, it used to be 6. Let's say it's about 3%. Okay, and I'm hoping you can see this. And let's say in this case that we draw a line out. Okay, and I'm going to draw another little dash right here. It says, okay, this is my market portfolio right here. All right, and this represents, to go back here for a second, this represents beta. Okay, we're going to put beta on the bottom here. We're going to call this the security market line. Okay, so basically everything that is over here, and I put my notes there, over here is overvalued, and I'll explain this in a minute. Everything that is up here is undervalued in terms of one asset or one stock. So we can actually hold all types of different assets or portfolios in this case, but we are looking at their market risk or market volatility, how they move with the rest of the market. So the beta of the market is thought to be about 1.0. Okay, again, the return of the market 12%. And looking at this, the way this was derived, the line equation for this line is actually the expected return, okay, is equal to the risk-free rate plus the beta of whatever asset we're talking about, less or times the market return less the risk-free rate. This is oftentimes termed the market risk premium. Okay, the rate above the risk-free rate that investors are willing to pay for a normal market asset. And knowing a beta of a stock, you can actually figure out what return it should be generating. So if you have one up here, let's say stock A, and it's making a return of about 14%, and yet this line right here, just as in right here, represents equilibrium in the market. So in this case, if you see a stock up here making about 14%, when in reality it should be making about 9%, you know that its price is going to go up, the price of the share per share, okay, and its return will go down, okay. This is the law of supply and demand and supply, okay. And so if you see it up here, you know that it's going to be undervalued. And same here. If you have a return here, okay, that's way out in this direction, again, you're going to see it move back up, okay, if it's got a rate of about 8%, and it's going to move back up into equilibrium, all right? And the price is going to fall, the rate's going to go up, and the rate of return, okay? And again, this is looking at the expected return. You can also use this to look at historical returns, all right? And so basically what they call this security market line, this model, or this, I don't want to say model, this line, okay, the equation line is used for the capital asset pricing model, okay, and used for a whole bunch of different reasons, to get the return, to be able to price a return on the market, to see if it's under or overvalued, to be able to come up with a discount rate, to be able to value a company. So that's many different reasons we use the CAPM. It's very valuable and very handy, okay? And again, the only difference between the capital market line and the security market line, the biggest difference is this is the market risk of a stock or an asset, to whereas this is the unique or specific diversifiable risk, okay? So I hope I talked a lot. I hope that made sense. And when we go back to this, I think I'm hoping that this will make some sense. Okay. And again, I'm looking at, just looking through here real quick. I think we pretty much covered everything. And right here, obviously, if what we're talking about here, now I want to show you one thing real quick that I haven't really talked about much, and that is, you know, most of the time we think of if we held a portfolio, let's say out here somewhere, some combination of stocks and bonds, okay, that was perfectly correlated. Yet we know that if we could hold it right here, we could earn the same return for a lot less risk if we just moved it into here, okay? So we could actually do this move, okay, if we use correlation to our advantage, okay? And that might mean changing the stocks that we hold or changing the weights of the stocks that we hold as well, okay? And then beyond that, not everybody does go for max return and minimize risk. This is what we call a rational investor, okay? And not all rational investors act alike. And this gets into a field of finance called behavioral finance, okay? And so anyway, just I wanted to share that with you guys and gals. And I think that pretty much does it. Just be aware of using the normal distribution in terms of describing the mean standard deviation. And I think that covers it. Oh, one last thing. The capital allocation line is when you just have one asset, okay? And let's say you have your portfolio and you introduce the risk-free rate, okay? You can hold different combinations, okay? And you can see that. In fact, I would really recommend looking at the video done by a gentleman by the name of David Hillier, okay? He is actually a pretty wise man, and this is what they call the capital allocation line, because it's just talking about basically the standard deviation versus the risk, standard deviation versus return based on what you hold, okay? If we change the correlation, it's going to change the curvature, okay, over time. All right, so with that, ladies and gentlemen, I am going to let you go, and you all have a great rest of your weekend, and I look forward to seeing you on Thursday. I will have also everything pre-recorded, just in case, but I don't think anything's going to happen, okay? And let me just flip this over, say peace. Thank you. God bless, guys. Take care. Almost forgot. Que Dios le bendiga.